ขอต้อนรับทุกท่านนะคะสู่การสัมมนาเรื่อง Circadian Lighting for Hospital นะคะเดี๋ยวก่อนอื่นขอแนะนำตัวนี้นะคะสำหรับท่านที่ยังไม่เคยเจอกันนะคะดิฉันผู้ช่วยศาสตราจารย์ดร.จัญญาพร จุฑามรัตน์นะคะเป็นอาจารย์ที่คณะสถาปัตยกรรมศาสตร์และการออกแบบมหาวิทยาลัยเทคโนโลยีพระจอมเกล้าธนบุรีนะคะแล้วก็เป็นผอ.ศูนย์วิจัยและนวัตกรรมการออกแบบด้านแสงสว่าง Lighting Research and Innovation Center เป็นศูนย์วิจัยที่ specialize ด้าน Lighting Design Research ที่เพิ่งตั้งขึ้นมานะคะของมจท.นะคะโดยเรามีความร่วมมือกับ Professor Michael Siminovitch นะคะจากท่านเป็นRosenfeld Chair แล้วก็เป็น Director จาก California Lighting Technology Center นะคะที่ UC Davis แล้วก็ท่านจะเป็นคนที่มีอิทธิพลต่อการทำพวกมาตรฐานด้านการออกแบบแล้วก็โดยเฉพาะทางด้านการประหยัดพลังงานของแสงสว่างนะคะแล้วก็อันนี้เป็น area ใหม่ที่ทางCLTC เนี่ยเขาก็ได้เริ่มทำนะคะแล้วก็เราก็จะเป็นพาร์ทเนอร์กันนะคะแล้วก็ดูทำการวิจัยในเรื่องนี้ต่อไปนะคะโดยในปัจจุบันเนี่ยเราก็มีความร่วมมือทำการวิจัยในด้านlighting design เป็นส่วนใหญ่ตอนนี้จะเป็นเรื่องของenergy efficient lighting นะคะแล้วก็เป็น lighting in workplace ทำเรื่องsmart lighting นะคะในปัจจุบันนะคะสำหรับวันนี้ก็การบรรยายโดย Professor Michael ก็จะประมาณ 45 ถึง 1 ชั่วโมงนะคะแล้วก็อาจจะเบรกแล้วก็แต่ว่าถ้าอยากจะถามอะไรก็ในระหว่างนี้ก็ยกมือได้นะคะหรือว่าถ้าจะให้ถามให้ก็ได้นะคะแล้วก็ในหลังจากการบรรยายสัก 45 นาที 1 ชั่วโมงโอเคถ้าเราทานเบรกกันแล้วก็กลับเข้ามาก็จะเป็น Q&A นะคะโอเคค่ะงั้นก็เชิญรับฟังการบรรยายจาก Professor Michael Siminovitch นะคะโอเค the floor is yours
Maybe we could turn off. So it's okay. First of all, I want to thank you all for coming today on your busy workday to come and listen to a professor from Davis. I want to also thank Professor Chatrium for inviting me here. We have a long partnership underneath the APEC agenda to collaborate between the University of California and the University at KMUTT. So we're doing a lot of collaborative efforts. Today I'm going to be talking about a project that we've just recently started at the University of California. And I'm collaborating with the chief architect for the university hospital system for the hospital network. The UC California has got one of the largest university-based hospital networks in the country. And we're involved now in a very large relighting program throughout the state of California. So I'm collaborating with the chief architect, Joel Swift, and also my graduate student, Talia, who's been working on circadian design for a number of years. The work was funded through Sacramento Municipal Utility District, which is a publicly owned utility, very interested in supporting innovation. And has a very close relationship with the medical school. And so I'm going to be talking about this protocol as kind of a unique opportunity for driving new design. And as I was saying, UC Davis is part of the University of California medical system, has a very large hospital structure, very engaged in research, particularly in the medical arena. And they're very interested in this whole concept of circadian design for driving new facilities. So what I'm going to be doing today is talking about a number of different design strategies that we're integrating together to form a specification for the new hospital and also to inform some of the relighting programs. California is in the middle of a very large relighting effort, and most of the public buildings are in the process of being relit. So what I'm going to be talking about is 5 or 6 different circadian strategies that all integrate into this kind of standard protocol that we're going to be applying to new hospital design. So I really wanted to focus on the issue of the disparity between conventional design that we normally engage in the evolution of healthcare facilities, but also in contrast to this new opportunity related to circadian design. And basically this has to do with the disconnect between our evolution in terms of our visual system and the way we light buildings. And there's a very significant disconnect between these two constructs. So I'm really looking at sort of the contrast between how our eyes have evolved over a very long period of time relative to the very unsophisticated way that we light hospital facilities today. And so there's a very strong there's a lot of literature on this relative to the evolution of our visual system and how it responds to light, both visually and also biologically. Very much driven by the intensity and the spectrum of exterior lighting, daylighting. And so our eyes have evolved under this kind of spectrum, which is very biased towards the red end of the spectrum, low intensities at both sunrise and sunset. At midday, characterized by a shift towards the blue end of the spectrum, very high color temperatures, much higher in intensity. And then, of course, the reverse, in which we see a marked shift towards the red-yellow end of the spectrum, much lower in intensity. So our eyes have evolved under this, and our biology has evolved under this, and the way our hormones are regulated, very much driven by the spectral distribution of daylight. And we disregard this in conventional design today. And I'm going to really sort of talk about that kind of contrast. Even on a cultural level, if you look at the bias towards red light sources in the evening, historically we've illuminated our places of work and places of living with very low color temperature light sources, flame, all kinds of black body radiators. It's only been in the last 50 years that we've moved to blue biased light sources or much higher color temperatures. And so there's a very significant disconnect on a biological level, but also on a cultural level. And I'm going to talk about that a little bit more. The way we've illuminated buildings mostly has been through black body radiators. Again, it's only been in the last 50 years where we're using phosphor-based light sources that bias towards the blue, in my mind, quite unfairly. And I'm going to talk about that additionally. So the kind of situation that we're in now, relative to this very large relighting effort, we're seeing this very significant transformation from traditional incandescent, phosphor-based fluorescent to now LED. And if you look at conventional design today in hospitals, and I'm working very closely with, again, one of the largest hospital networks in the United States, it's all fluorescent. We're at 99.9% fluorescent in our hospitals. And it's typically a luminance-based. We're using very simple luminance-based kinds of calculations. We employ very simple switching geometries inside these spaces, light switches, characterized typically by very poor color light sources, 80 CRI or lower. Typically constant CCT. In other words, the spectrum inside our hospitals doesn't change. And this is very, very significant relative to supporting biological wellness. One of the big issues I'm going to talk about is there's no darkness at night and significant blue light disruption. And this is across most hospitals design. And so when I looked at this in detail, virtually 100% of all hospital design in California is fluorescent based. It's probably very similar here. So this is the typical range of light sources that we see inside traditional hospitals. This is kind of a view inside typical bathroom space, and there's about $20,000 worth of upgrades to take care of ADA requirements for disabilities. And yet we've put about $200 worth of fluorescent inside this bathroom. So it's a very marked differential between what we spend on ADA relative to what we spend on lighting, and yet lighting is probably the main driver of biological wellness inside the space relative to circadian balance. So there's this really large disconnect between lighting design and wellness, but not a reluctance to spend money. Hospitals are prepared to spend a lot of money on patient wellness, but there's a very significant disconnect relative to lighting design. Okay. Can we turn off the sound system? Just turn it off. This is a spectral distribution of a light source inside a hospital. Very discontinuous light source. And this is typically very low color rendering. And so this represents a real departure from the way our eyes have evolved. Our eyes have evolved under a broad spectrum radiator, biologically and culturally, a broad spectrum radiator, either flame or incandescent light sources. And so the sort of main takeaway here is that in hospitals, we're using very poor color light sources. And I'm going to get into this in more detail. So not only is it poor color, but it's also very spiky, meaning that we have a strong spike in blue, green, and yellow, red. And the rest of the spectrum is much lower. This discontinuous spectrum causes all kinds of visual disruption. Given that our eyes are evolved under a very smooth radiator, and a black body radiator that we traditionally evolved under culturally is also very, very smooth. The other one is constant CCT. I could not find any protocols within the UC system that called for any protocol for spectral change relative to CCT. And I've not seen one. I know that some of the Europeans are working on this, but constant correlated color temperature, completely separate from what time of day it might be. The other issue is most of the light sources that we see inside hospital design are typically high correlated color temperature, 4,000 Kelvin and above. And we can get into a much longer discussion looking at the Asian preference for high correlated color temperatures, and we could have quite a discussion on that perhaps later. But most of the hospitals are characterized by very high CCT, which is extremely disruptive at night. So we're going to see a fairly large move in California to solid state light sources. So 50% of the marketplace by 2020 will be going to or by LED by 2020. So this is kind of an objective. Today, there are no design projects in the state of California that are not LED. It's all solid state. I'm in the process now of having all the fluorescents removed from UC Davis and UC Irvine as a standard policy. All hospitals moving forward will be solid state. So this represents an enormous opportunity, but what we're doing is we're putting in solid state technology using fluorescent specifications, which is completely wrong. So the challenge here is what to do. What's the appropriate specification for hospital? If every hospital in the state is going to be moving to solid state, what should we do? And that's sort of the reason why we're developing the UC Davis protocol to help planners and designers and say, do this. And this is what I'm going to be talking to you about today. So the opportunities here with solid state lighting is that we can do something better than fluorescent. Fluorescent is static, poor color, constant CCT, very spiky, bad color. And everybody agrees to this. Okay? So the opportunity with solid state lighting is that we have the potential to